All right, so I personally think graphing a reciprocal when you've got the graph that you're drawing the reciprocal of is much easier than trying to figure it out yourself. So the things you're looking for are when f of x equals 1, then 1 on f of x is also going to be 1. And when f of x is -1, 1 on f of x is also going to be -1. So we're going to go through this point here. And we're going to go through, I wish they'd sketched them, about there and about there. I'm going to change colours, you can't tell. Okay. So we're going to go through those points. The next thing we need to look for is zeros, which turn into asymptotes. So when f of x equals 0, 1 on f of x has an asymptote. Oh, this is vertical. So f of x is 0 here, so we're going to have an asymptote there, like it's never going to go through that point. It's going to curve around it. Same here. Okay, try for the horizontal asymptote. We can't do it algebraically, we don't know. So assume the horizontal asymptote at y equals 0 unless you're told y equals 1 on f of x plus some kind of other number. Like they'll always specify that. If you're just finding a straight up reciprocal, it's always y equals 0. And of most functions, obviously we had some weirder stuff going on up there. And finally, maximums and minimums. So if f of x has a minimum, which is like that, 1 on f of x has a max at the same x coordinate. So we're going to have a maximum, the maximum of this other one is obviously here, yeah? So we're going to have a minimum at the same kind of point. We already know it goes through that point, but shh. So here, the max at 2, 1, so f of x has a max. 1 on f of x has min at 2, 1 on 1, which is the same point. And then draw. You've got enough information because we know we can't kind of go down like that because that takes us right into the horizontal asymptote at y equals 0. We never get there, so we must go upwards instead. And this one, there's no way for this to behave except to go like that. Like it has to follow the asymptotes around. Let's have a look at B. So the first thing we check, I'm just going to give us some headings. Okay. So first thing to check, f of x equals 1, f of x equals minus 1. We're going to have the same thing, so let's put dots there. Well, this is f of x equals minus 1, and this is f of x equals 1, and this is f of x equals 1, and this is f of x equals minus 1. It's going to go through those 4 points. 1 on f of x goes through these points. Okay, zeros, which is f of x equals 0. We have vertical asymptotes. So here's a 0, so that's a vertical asymptote here. Here's a 0, that's a vertical asymptote here. Here's a 0, that's a vertical asymptote here. Horizontal asymptote at y equals 0. Because we've just been told a straight reciprocal. The whole thing hasn't been moved up or down. And if you do 1 divided by something, it's never going to come out as 0. And max and min. So f of x here has max at, so see how it's like that? F of x has min at, see how this one's going like that? So 1 on f of x has min at, it's going to have the same x coordinate, and then it's going to be 1 over the y coordinate. So it's going to be there again. And 1 on f of x has min at max at -1, 1 on -1, which is there again. Okay, so all up means we are going to have these going like that, so that's going to come down and up. That's going to go up and down, and these will just skirt. And they never cross the asymptotes. So that's what that's going to look like. Let's have a look at C. This is really interesting, this one. So let's just deal with normal. F of x equals 1 equals -1. The only point that happens is like here. So we know we're going to go through that point. Asymptotes are zeros. So we're going to have asymptotes there and there. Horizontal asymptote, so y equals 0. Like we haven't been told it's moving up or down. And let's look at the local maximums and minimums. So here you can see we've got a minimum at about 2. That's okay, we don't have to be that accurate. So we're going to have a max there. The y coordinate of that, I'd say it's like a half. Like, you can just guess. That's, sorry, negative a half. So ours will be 1 on negative a half, so negative 2. So I think that our thing will turn around at about here, and it's going to go down like that, okay? We've also been told that this bit is going to get closer and closer and closer to 2, but never get there. So that's technically, it's a local maximum. Wrong colour. Fx has, well, tends towards max at y equals 2. So this is when x is bigger than 3. So 1 on f of x is going to have a min. X is going to still be greater than 3. Y is going to be a half this time. So I think and that makes sense because our other f of x equals 1 came across here. So this one's going to kind of go around, instead of going all the way down to 0, it's going to go along to a half. It's a weird graph we're drawing from. This one's just going to go like normal. This one we also know how to deal with. These are some weird questions. You kind of have to actually think there's no one way of dealing with all of them. All right, let's do f of x equals 1 or minus 1. We're going to be at the same points. So we're going to go through these 3 points. Okay, now let's look at zeros. We're going to have asymptotes there and there. Y equals 0 horizontal asymptote. Like, it's always your default. If you don't figure out something like this, then where it was a half instead of 0, like, yeah, you treat it as 0. And then let's look at any maximums and minimums. So here you can see f of x has max at 0, 0. But we're not even going to get there, so it's not going to matter. F of x has min at x equals 1, y equals minus 1. So 1 on f of x has max at x will be the same. Y equals 1 on the y coordinate of the other one, which is minus 1, so it's going to be minus 1. So we're going to have a max there. So let's just draw something that goes through all these points. So it's going to kind of come around like that. It's going to come around like that. And it's going to come around like that.